I don't know if you've heard of it. But your water climbs up the sides. I want the bottom of the meniscus on the 250 milliliter line. So keep going, but you're going to have to get low, and then, because it's got a curve on the top, I want the bottom of the curve on that line. And if you mess it up, we've got to start this whole process again. And you don't have, no, you don't hold the bottle, you hold it upright and squeeze it.
Someone, look here.
No, then the lid is not on tight. Just tell me if it should squeeze easily. No. Yeah, so hold upright and squeeze it.
So what I am squeezing now, look here.
Okay, just see. Okay, slowly. Okay, you still got to wait a little way to go. So you got to.
On the line.
Okay, let's see if this is on the line. Jared says it's on the line. You know, the top's on the line, but you've got to get the bottom, so it needs about at least 10 more drops. Just keep going. Try this lid. Yeah, that's it. No, other way. And just screw it on nice and tight. Try it with just a few drops on the side. Just try it. Just try there. Okay. Great. Now that's working. Slowly, add a few drops. Now look at it and see if it's still a bit low. Yeah, the top is on the line, but the bottom is not on the line. You've got to get a little bit more. About 3 more drops. Or I'll tell you when to stop. More. Okay. More. 3 more drops. Okay, that's great. Thank you very much. Don't forget to sterilize your hand. Okay, well done. Now, what's wrong with that solution? It's got solids at the bottom. So you've got to stir it. So who's next to stir it? Fred, you sterilize your hands. So if you could sterilize your hands, Keza, and then stir it until it's all gone. Yeah. Sure. Use this thing called a pipette. It's not the correct one, but you might as well. Okay, so Terza is using a pipette. Now, Christian, how well is that dissolving? Is it longer or less long than the sodium hydroxide? So oxalic acid is even slightly less soluble than sodium hydroxide. Perfect. That thing she's stirring it with. That long thing, that long tube. Perfect. We're going to use the perfect in a moment. Listen. So Treasure, is the last grain gone? Was there one more stubborn grain left in there? I see one little grain floating in there. Always happens. What is that? That's what you're in. Okay, now,
So it's a piece of thing. It's not a grain.
it's a non-dissolving thing.
It's a thing.
You see, if it doesn't dissolve, then it's added a little bit of weight to that. And in theory, we should start over. But are we going to start over?
Yes.
No. Thanks a lot. No, I think it's gone. Yeah, there's still one little Magodi in there. Okay. What you should do is not use one of these because we want to make sure that our solution volume stays the same. So I'm going to just, yeah, it's the same. Okay. So we got 250 moles solution, and we got that number now. Now it says 250 milliliters. Who knows how many decimeters cubed 250 milliliters is? Do you know how many milliliters there are in a decimeter cube? A lot. 1,000. So this is a quarter of a decimeter cube. All happy? Because we want our concentration in moles per decimeter cubed. Now this is what you guys are going to do. You're going to say, it's all part of your method, you're going to work out the concentration of that oxalic acid solution using the formula, okay, oxalic acid concentration. Now, what is concentration always equal to? What is the answer of it? What is the unit of concentration? Moles per decimeter cubed. That's what its unit is. So what is the unit for moles? N. What is the unit for decimeter cube? V. Sorry, V. So C is number of moles over volume. Moles per decimeter cube. What is our volume here? It's a quarter of a decimeter cubed because it's 250 moles. So we already know the volume. Now, how do we find out the number of moles? Mass, little m over molar mass. What is this mass? We weighed it out, 3,3 grams. Now all we need is the molar mass of oxalic acid. So, if we want the molar mass, we need the structural or molecular formula. So here is oxalic acid. It's C, double bond O, double bond O, OH, OH. So it's H2C2O4. But when you make it, when you crush it and get it out of the 4-leaf clover, rhubarb, 4-leaf clover, rhubarb, Swiss chard, anything that's sour like that, oxalic acid, it forms two waters with it. It locks in two waters with it. That is called water of crystallization. Okay. Now, let's work out the molar mass. Who would like to tell me what the molar mass is? Each H is on the periodic table a mass of? 1. Each carbon's a mass of? 12. Each oxygen's a mass of? 16. And don't forget, 2 times H2O, H2O is 18. Because it's 16 plus 2 times 2, 18 times 2 is 36. Okay, so don't forget to just add all that stuff up and then you'll get the molar mass in grams. Did we lose anybody here? So there's a formula, but it locks in 2 waters with it. Add them all up and get your molar mass in grams. Who's got an answer? Just put a hand up, but don't tell us. The molar mass. Need a calculator to add them all up. Who's added these all up? So 218 to 36, I think that oxygen is 64, 36, 40, 100, 2 carbons and 24, 25, 26. That's what I get, but I don't know if it's right. I get 126, but I could be wrong. 126? Okay. So that's the molar mass. So, how about working out the concentration? Put work out the mass upon the molar mass and put it there as the number of moles over the volume and get the concentration. So you've got 3.3 over 126. That answer over a quarter. Over 0.25. And there you've got your answer. Got an answer for us as well?
I got 0.10.
There. Anyone else get that? There we go. So that is our concentration of oxalic acid. And it would be in moles per decimeter cubed. So folks, that, if we know its concentration, is known as a standard solution. It's a standard solution. Was our sodium hydroxide a standard solution? Who would like to answer that? Was our sodium hydroxide a standard solution?
No.
Because we don't know its concentration. So as long as we've got one solution that's a standard solution, we can proceed. Okay. So, here we're going to write on this oxalic acid 0.105 moles per decimeter cubed. So there's our two solutions that we're going to titrate together. All happy? All happy?
Yes,
Okay. So just to show you more or less what we're going to do, we're going to take an amount Okay, let's just show this on the camera. What I'm going to do is I'm going to take an amount of oxalic acid. I'm going to put into it some stuff called phenolphthalein. It's a white powder. But I don't need much of it. It's an indicator. It's an indicator. What color is it in acid? What's that color? Colorless, right? Then I'm going to take sodium hydroxide and I'm going to pour it in, and notice that as I pour it in, it gets that pinky color. So I'm going to keep doing this until one drop turns it pink. Sorry, Tom? Just say that again.
Before you do this, sodium hydroxide, what is inside?
Just oxalic acid and phenolphthalein. So now I'm going to keep on adding until one drop turns it permanently. Now do you see that I obviously stuffed up, right?
Yes.
But I'm just giving you the idea of what we're trying to do. So if I want to turn it back, I just add some more acid.
Magic.
But I've got to get it to the point where one drop turns it. Okay. Now this is what I'm going to do. I've got two pieces of apparatus here called burettes. Now someone's going to have to do this, so watch carefully. These things, this is where we might stuff up completely because these taps tend to stick. Oh no, and we've only got one of them. Oh, there we go. Ooh. It will run out when it's. We'll have to maybe push something in there. So we're going to run all the sodium hydroxide out, and if not, I've got to find a pin and stick it up there. I think it's blocked or something. Locked? Maybe it's blocked in the tap. But anyway, those taps have to run freely. And this tap is not running, so I need something like a basin. I've got to get this to run. Are we on camera? Okay, so it's running freely now. Whoops, there we go. Okay, so I want that old sodium hydroxide all out. Then I wash it. Now, the sodium hydroxide is bad for your eyes. Don't get it into your eyes.
Eyes are really bad.
So I'm going to just wash it out with our fresh solution of sodium hydroxide. Close the tap. Put it back in. Clamp it. Okay, now we need someone who's going to fill this with sodium hydroxide and then run it out. This is a difficult job. You're going to stuff it up probably. But I need someone who's going to try it.